Hello everyone. So I hope you all are very well and learning yourself. So today I am in front of you. I have bring a topic that is how to find the eigenvalues and an eigenvector. So this topic basically you have already maybe learned in class 12 also. So you will also learn it in the first year of your engineering college. So let's start how to find the eigenvalues and eigenvector. Okay. So basically eigenvalues and eigenvector can be found for a matrix, and that matrix must be a square matrix. Like its order must be same. It must be a square matrix. Okay. So if somebody asked me how to find the eigenvalues for this and how to find the eigenvector for this, so how to find these things, we have to see this. Okay. So basically there will be one term, that is ax will be equal to lambda into x. Okay, and x will be what? X will be eigenvectors. Okay, and here lambda is what? Lambda is any scalar quantity. Okay, so here ax minus lambda into x is equal to 0, and from here you can say that a into lambda I into x is equal to 0. Okay, so this is what? This is the eigenvector. This is eigenvector, and what is the lambda here? Lambda, I have already told you, it's a value, it's a scalar quantity. Okay, it may be anything, it may be like 0, 1, 2, anything, it may be also complex, no matter. Okay, so what will be our eigenvalues? This will be eigenvector, and then what will be our eigenvalue? Eigen will be simply the determinant of a minus lambda into I. This will be our eigenvalues. So let's see an example. So let A be any matrix of square that is 1, 2, 2, 1. It's a square matrix of order 2, and we have to find eigenvalues as well as eigenvector. Okay, so to find eigenvalue, what we have to do? We have to just A minus lambda into I, just determinant of this, and for eigenvector we have to find A minus I lambda into x. Okay, so let's firstly find the values of the lambda. Okay, so now I is what? I is just an identity matrix, this, and when we write A minus lambda into I, then we can say that it will be what? It will be 1 minus lambda into 2 and 2 and 1 minus lambda. Okay, so to find the A minus lambda I is determinant, we have to find the determinant of this quantity. Okay, so just minus 4. Okay, so from here we can get the values of eigenvalues. So we have to find the eigenvalues. Let's do it. And from here, when you solve this, you get the values of lambda minus 1 and 3. Okay, so these are what? Lambda is equal to minus 1 and lambda 3. We are getting the values of lambda 2. Why? Because this is the second order matrix. Okay, if we are here 3 order matrix, then it will be 3 values of the lambda, and there will be 3 eigenvalues. Okay, and just here there are only 2 eigenvalues, that is lambda is equal to minus 1 and 3. Okay, so now we have to find what? We have to find the eigenvector. To find the eigenvector, we have to see how to find the x. Actually here there will be 2. For lambda is equal to minus 1, there will be x1, and for lambda is equal to 3, that there will be x2. Okay, so for different values of lambda, you will get the different values of eigenvector. Okay, so we have successfully found the eigenvalues, and now let's see how to find the eigenvector. Okay, so to find the eigenvectors, we have to just put each lambda value in it, and let's see how to do. Okay, so here just like I have written so 1 minus lambda 2, and here 2, and 1 minus lambda into x1 x2 is equal to 0. Okay, so for lambda is equal to minus 1. Okay, when you will put minus 1, what you will get? Here putting minus 1, 2, 2 and 2. Okay, and here x1 x2 is equal to 0, and you can write like this 2 plus x1 plus 2 times x2 will be 0, and from here 2 times x1 plus 2 times x2 will be 0. Again same equation. Okay, so from here you can say that x1 is equal to minus times x2. Okay, so from here you will again get x1 is equal to minus x2. Okay, so I am saying that let x2 will be 1, and then x1 will be what? Minus 1. Okay, you can also assume that x1 is equal to minus 1, and then x2 will be 1. Sorry, x1 will be plus 1 and x2 will be minus 1. Okay, so you can assume anything, like I have assumed that x2 is equal to 1 and x1 will be minus 1. So from here you can say that x1 means capital X1 means what? Eigenvector. Eigenvector is what? Minus 1 comma 1. Okay, so it may be different values if you are assuming the different values of x1 and x2. Okay, so I have taken x2 is equal to minus 1 as an arbitrary constant. Okay, you have to take it. Okay, so I have just found for lambda is equal to minus 1, we have found x1 is equal to minus 1 and 1. This was our eigenvalue and this is eigenvector for lambda is equal to minus 1. Okay, now let's see for lambda is equal to 3, what will be our eigenvector? Means x2 will be what? Okay. So just putting the value of lambda is equal to minus 3 in this equation, you will get what? When you will lambda is equal to 3, it will be minus 2 and 2 and 2, here will again minus 2. Okay, and this is what? x1 x2, this is equal to 0, and just writing the equation minus 2 times x1 plus 2 times x2 is equal to 0, and from here 2 times x1 minus 2 times x2 is equal to 0. Okay, so from here what you can say that? You can say that x1 is equal to x2. Okay, and now let's again assume let x1 is equal to 1, then x2 will be what? Again 1, because both are equals. So from here you can again see that x1 and x2 both are equals. You can take any value. I have just assumed 1, you can assume minus 1, you can assume 2 or any values. Okay, so x2 will be what? The second eigenvector will be 1 1. Okay, so for lambda is equal to 3, we get the eigenvector 1 and 1. Okay, so for the different values of lambda, you will get the different values of the eigenvector. Alright, so this was all about the eigenvectors and eigenvalue. I hope this video will be very helpful to you. If you are facing any problem with eigenvector and eigenvalue, you must watch this video. And also don't forget to like and comment, and also subscribe my channel. So because I am working and I am just trying to help you all. Okay. So I hope this was helpful to you. Thank you.